Just like in the previous video, we'll start by going through what independent events mean. When two events are independent of each other, the probability of the first event is not affected by the second. To help make sense of that, let's consider flipping a fair coin twice. If you flip the coin once, what is the probability of getting heads? The probability would be half or 0.5. If I flip the coin again, what is the probability of getting heads on the second toss? It is still 0.5. The probability did not change for getting a heads. What if we got a question like this? A fair coin is flipped twice. What is the probability of getting heads twice? A way we could find out is by writing all the possible outcomes of two coin tosses. There could be heads heads, tails tails, heads tails, and tails heads. Out of those four possible outcomes, how many have heads twice? 1 out of the 4. Therefore, the probability of getting heads twice is a quarter, as there is one possible outcomes out of 4, 1 over 4. A slightly different question. A fair coin and dice are tossed. What is the probability that the coin lands on heads and the dice lands on 4? Once again, we can identify all the possible outcomes of a coin and dice toss. Out of the 12 outcomes, half have heads, and from the half, a sixth is a 4. Therefore, the probability is a sixth of a half. When we try to find a fraction of a number, it's the same as a multiplication calculation. So the probability is a half multiplied by a sixth, which is the same as saying a sixth of a half, which is 1 over 12. Pause and have a go at this question. Once again, we can write out all the outcomes. We can see that the probability of landing on a 4 for the first toss is 1/6. For the second toss, landing on a value less than 3 is 2 out of 6, as 1 and 2 are less than 3. As we can see again, the probability would be 2/6 of 1/6, which is equal to 2/6 multiplied by 1/6. The final probability is 2 out of 36. We can simplify the fraction to 1 over 18 by dividing the numerator and denominator by 2. Writing out all the possible outcomes can be quite time-consuming, so a quick way to answer the question that you may have noticed is to just multiply the probabilities of each event. Let's try with this question. Sam is playing a game. The probability he wins is 0.4. The probability that he draws is 0.2. He plays 2 games. What's the probability he draws the first game and wins the second game? Since we're looking for the probability where a draw and a win occurs, we multiply the probability of a win and a draw. So the answer would be 0.4 multiplied by 0.2. The final answer would be 0.08. We can look at this visually, like we've done in the previous questions. 0.2 of his games will end in a draw, so 0.4 of those games would be wins. 0.4 of 0.2 is a multiplication of 0.4 and 0.2, which gives us the same answer as before, 0.08. We can use this technique to calculate the probability of more complex questions, such as the probability of flipping a coin 4 times and landing on heads each time. We could write out all the possible outcomes of flipping 4 coins, but once again, that could be quite time-consuming. Each coin's probability for heads is still 1/2, and this happens 4 times. The answer would equal to half times by half times by half times by half. The final answer would be 1 over 16. Pause and try these questions. Once again, we identify the probabilities we want. 70% of the time, the 225 comes first, and 25% for a baby being on the bus. We multiply the probabilities to give us the final answer. To multiply percentages, it would be easier to change the percentages into fractions than multiplying. 70% as a fraction is 70 over 100. Simplified, that is 7 over 10. 25% as a fraction is 25 over 100. Simplified, this is 1 over 4, or a quarter. Multiplying the two fractions gives us the probability 7 over 40. This is the final answer. To summarize, when two events are independent of each other, the probability of the first event is not affected by the second. When finding the probability of events occurring, multiplying the probabilities of each event gives the final answer.